Hi friends, today also we are discussing about some more important terms remaining in the physical pharmaceutics 2 coming in 4th semester B Pharm as a part 2. So today we are going to discuss about what is Hardy-Schulze rules and more concept. So Schulze-Hardy rule or Hardy-Schulze rule, it will state about the precipitating power of an ion on a dispersed phase of opposite charge increases in what manner? Means it increase with increase in the valence or charge of the ion. So it will give an idea what is the precipitating order of an ion if we are increasing the valency or charge of an ion. So it will be more clear by seeing this diagram. For example, if we are adding a lyophobic alloy which is having a positive charge. So to that positive charge lyophobic alloy, we are adding opposite charge. Let it be electrolyte. So what happened? This positive and negative get physically absorbed and result in the flocculation. And that flocculated thing we are calling a secondary minimum as per the potential energy curve, right? So what is the order of vacancy of the effective ions? So if the ions category is like this, we are able to find out what is the precipitation order. So this is the precipitation order of cation. Aluminium Al3 plus greater than barium greater than sodium ion. And for anion, you can see the thing like this: ferric cyanide, sulfate, chloride. So this is the example for showing the precipitating power of a. Next one, we are thinking about Stokes law. So whatever any suitic subject we are going across the Stokes law. So it is shows or the Stokes law gives a representation of the rate of sedimentation of the particle. So if anyone is asking how you can express the rate of sedimentation, we can obviously or clearly cut the thing and state it like that. The rate of sedimentation of a particle can be expressed with the help of Stokes law. And that Stokes law equation is like this. Rate of sedimentation is equal to d square into rho 1 minus rho 2 into g divided by 18 eta, where small d is the diameter of the particle, rho 1 is the density of the dispersed phase, rho 2 is the dispersion phase density, and eta is the viscosity, and g is the acceleration due to gravity. But this Stokes law can be applicable only in two conditions. First one, the particle should be spherical. But in the suspension, all the time we cannot assure that the particle should be spherical. Sometimes it is irregular. So in that case, we cannot apply this Stokes law. Second thing is that the particle should settle freely and independently. Means this can be possible only in case of dilute suspension. That means most of the suspension which is having a concentration to 5 to 10% or higher, right? So at that times we are unable to explain the with the help of Stokes law. Next, we are telling what it is the difference between particle size distribution and particle number. So you may get a question of 5 marks or 2 marks, whatever it is. The distribution of the particle can be expressed with the help of so many things. First one is like this. It's a first distribution curve. We are calling it as frequency distribution curve. Frequency means how many times. Means number of weight of particle lying within a particular range. We are plotting with the mean size. Okay. So normally this normal distribution curve will come in the bell-shaped curve, or we are calling symmetrical curve around the median or mode. Second one, we are calling this is the normal distribution bell-shaped. Next one is like that. This is a normal distribution curve for a powder. So what we are doing is that we can see some uneven distribution around the mean, right? This one shows the number distribution, and this one show the weight distribution curve. And next one we are calling it as, we want to plot in logarithmic curve, we are calling it as log normal distribution curve. So these are the various curve we can see in this, and one more is the we are calling cumulative frequency distribution curve. So various curve. Next, you have to know you may come across two terms. One is half life and second is shelf life. Half life means what is the time required to reduce the concentration of the reactor to half of its initial concentration. Right? Let it be CT is the initial concentration. So, what is the time required to reduce to half means C0 by 2. So, this half life can be calculated by reading the time scale in the plot against concentration versus time. Whereas shelf life means what is the time required to reduce the concentration not to one half reactant to 90 percentage of this initial concentration, and can be expressed CT is equal to 90 by 100 into C0. So according to the reaction rate, it will this half-life equation will have and shelf-life equation will vary. Next question is like this: pseudo-order reaction with example. So pseudo whatever pseudo means it is a fall, right? So actually this reaction is originally a second order, but it second have to be, but it behaves like a first order reaction. So this reaction can be expressed as minus dc by dt into k1 into concentration of ion. The example, with the example they are asking you to write, so you can write the example as hydrolysis of ester catalyzed by hydronium ion. So what happens is that here hydrogen ion concentration will become constant, and this rate of the reaction depend on concentration of the ester. So that is a better example to explain pseudo-order reaction. And second one is base catalyzed oxidative degradation of prednisolone in solution. Next question is like this: what do you mean by phase inversion? Means if the emulsion type is oil in water, if it is changing is water and oil, we can call it as phase inversion. And this phase inversion is a sign of instability. Hope this concept will be helpful for you. If you find useful, please share to your friends. Thanks for watching.